Hi everyone, welcome back to Wednesday Math with Emily. In last video, we used math to find the biggest flower in the field. And the answer is to skip the first 1/e% of the flowers and then pick the one that is biggest so far. You will get the highest probability to get the biggest flower then. The E is also called the Euler's number. It's named after a Swiss mathematician called Leonard Euler. The number E is one of the most important numbers in mathematics, alongside with 0, 1, pi, and the imaginary number I. All of the 5 numbers play important and recurring roles across mathematics. Similar to the constant pi, E is an irrational number, meaning it is not a ratio of any two integers. Also like pi, E is transcendental. It is not a root of any non-zero polynomial with rational coefficients. The first reference to the constant were published in 1618 in the table of an appendix of the work in logarithm by John Napier. However, this did not contain the constant itself, but simply a list of logarithms calculated from the constant. It is assumed that the table was written by William Oughtred. The discovery of the constant itself is credited to Jacob Bernoulli in 1683, who attempted to find the value of the following expression, which in fact is E. What does this expression mean? The meaning of E is the maximum of the continuous compounding for 100% growth in one time period. For example, with 100% growth without compounding, you will get 200 at the end of the time period. If you compound it twice, you will get 1 plus 1/2 parentheses to the power of 2, so you will get 225%. If you compound it 3 times, you will get 237%. So the more you compound, the more money you will get at the end of the time period. However, there is a maximum, which is E. It's approximately 271.82%. This natural number E has many other applications. For example, it can be used in the Bernoulli trials. The number E itself also has application to probability theory, where it arises in a way not obviously related to exponential growth. Suppose that a gambler plays a slot machine that pays out with a probability of 1 in n and plays it n times. Then for large n, such as 1,000,000, the probability that gambler will lose every bet is approximately 1/e. For n equals to 20, it is already approximately 1/2.79. Another application for the natural number E is derangement. It is also discovered in part by Jacob Bernoulli along with Pierre Raymond de Montemort. It's in the problem of derangement, also known as the hat check problem. N guests are invited to a party, and at the door, each guest checks his hat with the butler, who then places them into n boxes, each labeled with the name of one guest. But the butler does not know the identities of the guests, and so he puts the hat into the boxes selected at random. The problem of the de Montemort is to find the probability that none of the hats gets put into the right box. The answer is also 1/e. There are more applications for E. For example, it is commonly used in calculus. It is the only number whose derivative equals to itself. Also, the derivative of log E of t equals to 1/t. And in integration, when we integrate from 1 to e of 1/e, the area under the curve 1/e equals to 1. Last but not least, E equals to the sum of an infinite series, which is 1/0 factorial plus 1/1 factorial plus 1/2 factorial all the way to 1/infinity factorial. The sum equals to E. So now that we know so many applications for E, no wonder it is called natural number. It contains everything. If you like this video, please give me a thumbs up and subscribe our YouTube channel and follow us on Instagram and Facebook.